Welcome to the acid and base game. Can you calculate for acids and bases? We're about to find out. How this game is going to work is a question or questions are going to appear on your screen. You are then expected to pause the video and try and solve the answer for yourself. Once you've solved the question, I want you to unpause the video and see the answer. If you got the answer right, awesome, skip ahead to the next question. If you got the question wrong, stay tuned because I will work out the question on your screen in front of you. Then it will automatically move to the next question and you can try your skills again. There'll be some additional practice problems at the end of the game for you to continue to test your skills with. So let's get going. For question number 1, you are asked what is the pH of 0.0110 molar HCl solution? Is this acidic, basic, or neutral? Pause this video and come back once you have your answer. All right, you got the correct pH if you got 1.96, and you answered number 2 correctly if you identified that as acidic. It is acidic because 1.96 is less than 7, and a pH of less than 7 is automatically acidic. Now, if you didn't get the answer right, let's figure out how you would have gotten it. The formula that we use for this is that pH equals the negative log. And if you couldn't find that log button on your calculator, watch the video I posted yesterday that goes over how to use your calculator. And then you put the hydrogen ion concentration in there. So we are going to put 0.0110. We'll then close those parentheses, and if you enter that into your calculator and round to 3 sig figs, because our number up here had 3 sig figs, you'll get your correct answer. Question number 2 asks you, what is the hydrogen ion concentration of a solution with a pH of 7.41? Is this acidic, basic, or neutral? Pause your video and come back when you have your answers. All right, you got the correct answers if you got a hydrogen ion concentration of 3.89 times 10 to the negative 8th molar, and if you correctly determined that this was a basic solution because the pH of the solution is greater than 7, and all pHs greater than 7 are basic. Now, how did I calculate this one if you got it wrong? Well, you use the formula that the hydrogen ion concentration, remember our brackets mean concentration, is equal to 10 to the negative pH, so in this case 7.41. Once again, I rounded to 3 sig figs here because I had 3 sig figs given to me in my problem. Now let's kick it up a notch with question number 3. In this question, you are asked what is the hydroxide ion concentration of a substance that has a hydrogen ion concentration of 1.2 times 10 to the negative 5th molar. Pause this video, solve your answer, and come back when you're done. All right, so this one was a little bit tricky because there wasn't just one formula you had to use. You in fact had to use 3 formulas, and if you used all 3 of them correctly, you got the correct answer of 8.3 times 10 to the negative 10th molar. If you didn't get this answer, let's look at how we would have done it. So for these kind of problems, I like to set up my game plan of what I'm going to do. So I know I am starting with my hydrogen ion concentration. The only thing I know to do with a hydrogen ion concentration is convert it to pH. That is the only thing I have in my arsenal of formulas to use. From pH, I know how to very easily go to POH. And then from POH, I know how to go to the hydroxide ion concentration. So based on that, let's get to work. So I know, and we've already done this once before, that the pH equals the negative log of a hydroxide ion concentration, which in our case was 1.2 times 10 to the negative fifth. Now keep in mind with these, you don't want to round too soon. So either you could use the whole number in your calculator or carry it out to 4 decimal places. So we would have gotten 4.9208 for that answer. Our next step was a super easy one because you know that pH plus pOH have to equal 14. So that means if we take our pOH and have it equal to 14 minus the pH that we just got up there, we get a pOH that is equal to 9.0792. But once again, the problem wasn't asking for the pOH. It wanted the hydrogen ion concentration, hydroxide ion concentration, which meant we had one last step to do, where we know that the hydroxide ion concentration is equal to 10 to the negative pOH, which in our case is 9.0792. And once we enter that into our calculator and round to 2 sig figs, because our starting number had 2 sig figs, we get our answer. Oh, that was a long one. If you got it right, you're probably doing pretty good with this stuff. If you got it wrong, don't worry, still plenty of practice problems ahead. So question number 4 asks us, what is the pOH of a solution with a pH of 5? Is this acidic, basic, or neutral? Pause this video, come back when you have your answer. All right, you should have gotten a pOH of 9, and you should have gotten this was acidic because we had a pH of 5, and 5 is less than 7, making it acidic. Now, how did I get the pOH? This one is super simple, where we know that pOH is equal to 14 minus the pH, which is 5, and 14 minus 5 equals 9. Question number 5 asks us, what is the hydronium ion concentration of a substance with a pH of 4.21? Is this acidic, basic, or neutral? Pause the video and come back when you're done. So for this problem, you should have gotten a correct answer of 6.17 times 10 to the negative fifth molar as your hydronium ion concentration. And you should have quickly determined that this was acidic because the pH of the substance is less than 7. If you didn't get that as your answer, let's take a look at how you would have gotten that. So we know that the hydrogen or hydronium ion concentration, remember they can be used interchangeably, is equal to 10 to the negative pH, which in our case is 4.21. We then rounded to 3 sig figs because our starting answer had 3 sig figs. For question number 6, you were asked what is the hydronium ion concentration of a substance with a 6.2 times 10 to the negative third hydroxide ion concentration. Pause this video and come back when you have your answer. All right. If you got the answer of 1.6 times 10 to the negative 12th, you got the correct answer. If this isn't the answer you got, let's see how you would have gotten that answer. So once again, for longer problems like this, I like to set up a game plan. where I know I am starting with my hydroxide ion concentration. That's what the problem told me. The only thing I know to convert a hydroxide ion concentration to is POH. I am limited by the number of formulas I have at my disposal. I then have a formula in which I can interchange between POH and pH. And then last but not least, I know how to go from pH to the hydronium ion concentration, which remember is the same as the hydrogen ion concentration for our purposes. So let's get started. You would have wanted to do that POH is equal to the negative log of the hydroxide ion concentration, which in the case of this problem is 6.2 times 10 to the negative third. And once you've entered that into your calculator, you would have gotten the answer back out of 2.2076. From there, you are going to do that your pH is equal to 14 minus your POH giving you a pH in this case of 11.7924. That leaves us our last step of doing our hydrogen ion or our hydroxide ion concentration, where the hydronium ion concentration, H3O plus, is set equal to 10 to the negative pH Then we round to 2 sig figs because our starting number had 2 sig figs. In question number 7, you're asked, what is the pH of a substance with a 7.4 times 10 to the negative third hydronium ion concentration? Is this acidic, basic, or neutral? Pause this video and come back when you're done. You got the correct answer if you got 2.1 and determined that that meant it was acidic because that is a pH of less than 7. If you didn't get this answer right, you would have solved this problem by knowing that the pH is equal to the negative log parentheses of the hydronium ion concentration, which in this case is 7.4 times 10 to the negative third. Then you round this answer to 2 sig figs because your answer up here had 2 sig figs. Question number 8 asks us, what is the POH of a substance with a 6.2 times 10 to the negative third hydronium ion concentration? Pause this video, answer the question, and come back when you're done. All right, you got the correct answer if you got 12 as your POH. If you got 12, great job, move on. If you didn't, let's look at how I got that. So we know that we are starting with our hydronium ion concentration. The only thing we know to convert a hydronium ion concentration to is pH. But the problem wants POH, but that's fine because we know how to convert from pH to POH. So let's take a look at what the steps to this problem would have looked like. We would start off by doing the pH equals the negative log of our hydronium ion concentration, which in this case was 6.2 times 10 to the negative third. When you enter that into your calculator, you would have gotten an answer out of 2.2076. Then we would have done that our POH equals 14 minus 2.02 76. When you got your answer out, you would have rounded to 2 sig figs because our starting number once again had 2 sig figs to it. Question number 9 asks us, what is the hydroxide ion concentration of a substance with 8.7 times 10 to the negative 8th hydronium ion concentration? Pause this video and come back when you have your answer. All right, you got the correct answer to this problem. If you got 1.1 times 10 to the negative 7th, let's take a look at that. Hopefully you got this one right. If you didn't get it right, let's take a look at what we would have done. So just like we have before, we are starting with a hydronium ion concentration. The only thing we know to convert hydronium to is pH. The only thing we're able to convert pH to is hydronium or POH. We obviously don't want to go backwards, so we know we need to continue moving forward to POH. And the only thing we know how to convert POH to is either pH or the hydroxide ion concentration. And since we don't want to go backwards, we know that hydroxide ion is going to be our next thing. And that's what our problem was asking us for. So that's obviously the correct course of action. So now let's look at how we would do this. So we would start off by knowing that the pH is going to be equal to the negative log of our hydronium ion concentration, which in this case was 8.7 times 10 to the negative 8th. When you enter that into your calculator, you would have gotten out 7.0605 as your answer. From there, we do that POH is equal to 14 minus the pH and that gives us a POH of 6.9395, which leaves us our last step where we know that the hydroxide ion concentration is equal to 10 to the negative POH and then we're going to round it to 2 sig figs because our starting number had 2 sig figs. All right, let's try number 10 on for size. This time you're asked, what is the hydrogen ion concentration of a solution with a pH of 9.84? Is this acidic, basic, or neutral? Pause this video and come back when you have your answer. You got the correct answer if you got a hydrogen ion concentration of 1.45 times 10 to the negative 10th. And you determined that this was a basic solution because it had a pH of greater than 7, and all pHs greater than 7 are basic. If you got this wrong, all you had to do was follow the formula that the hydrogen ion concentration, keep in mind hydrogen ion and hydronium ion are the same for our purposes, is equal to 10 to the negative pH and since our starting number had 3 sig figs, our answer will also have 3 sig figs. All right. By now, you should have a better handle on this than you did before. So that means that our next 5 questions, I'm not going to work out. I'm going to give you the question, and I'm going to give you the answer so you can see how you did. You're always welcome to contact me for extra help if you need it. So let's take a look. You were asked to fill in the remaining information in the table. You were told that this is a completely neutral solution. Pause this video and come back once you've filled in the other 4 blanks. All right, this one was actually super simple if you knew what you were doing. There is only one pH that is neutral, and that's a 7. So if you knew that your pH was 7, it was pretty easy to figure out the rest of it because that meant your pOH was also 7, and you could do the calculations from there. Let's try a little bit of a different one. On this one, you are still asked to fill in the remaining information on the table, but this time you're told that the pOH is 10.8. Pause this video and come back once you've filled in our other blanks. All right, the other blanks in this one, you would have gotten a pH of 3.2, which would have told you that the substance is an acid, because remember, only our pH can determine whether something is acidic, basic, or neutral. The pOH does not determine that for us. Then you could have, once you had those 2 numbers, you could have calculated your hydrogen ion concentration and your hydroxide ion concentration from there. Let's try question number 13. This time you're told that the pH is 9.7. Fill in the rest of the information by pausing this video and coming back when you are done. All right, on this one, you should have determined that it was a base because the pH was greater than 7. It should have then been very easy to figure out the pOH, and from there you could figure out your hydrogen ion and hydroxide ion concentrations. Now I want you to fill in the table knowing that you have a hydroxide ion concentration of 1.5 times 10 to the negative 4th. Pause this video and come back once you've filled in the other 4 boxes. All right. If I was solving this problem from my hydroxide ion concentration, I would have determined the pOH next. From the pOH, I would have determined the pH, and then from the pH, I would have determined my hydrogen or hydronium ion concentration. We would determine this to be a base when we figured out that our pH was a 10.2. And last but not least, I want you to fill in the remaining information on the table, given that your hydrogen ion concentration is 0.046 molar. Pause this video and come back once you've filled in the other 4 blanks. All right, you should have gotten that you had a 2.0 times 10 to the negative 13th hydroxide ion concentration, a pH of 1.3, and a pOH of 12.7, indicating that this was an acid to you. Hopefully now you're a master of these problems. If you're not, feel free to ask me any questions that you have, and I will be glad to help you out. You have a quiz coming up next week with this material, so make sure you're prepared to answer these style problems.